Uh, Thanks a lot for an opportunity. So today, my topic of the seminar is value engineering in automotive application. Uh, yes. So what I want to have time here is almost 1.5 hours plus. So I request to the participants, if in case if it is getting delayed, I request you to be here because I want to plan. I'm having some of the case studies which I want to share it. It may take some time, 5 to 10 minutes extra, so kindly bear. And uh, today, the seminar, as I said, it's a value engineering, which is the need of the hour during this COVID situation. And stated by Mr. Wengi, he said that whatever the cost saved is again a profit at this point of time. Yes, we are going to deal with the not only the cost saving but also how we are going to achieve the functions in order to increase the value to the product, process, projects or services. You can note on my email ID. It's p.arjunraj@gmail.com, and you can even note on my mobile number. It's 8778983428. You can feel free to contact me if in case any clarification with respect to the topic, even after the seminar as well. Let us go to the topic. So why are we here today? We are here today to increase the value that we can provide to our clients and customers. So at the end of the day, the clients and customers, they are the okay. So we need to provide the value to them. And we need to provide a value without any compromise on the parameters, which includes the performance, quality, reliability, maintainability, safety, and also the environmental norms. So without any compromise on all these parameters, we need to provide the value. It's not that we are going to provide the value by compromising on all these parameters. So we should provide a value without any compromise on all these factors. If in case if we compromise on the factors which starts from performance, quality to the environmental norms, what happens is that you cannot satisfy the clients or the customers. Okay, so ultimately your brand image or you will go out of the market basically. You will go out of the competition basically, and you will not get valued by your customers or your clients, and this may result in the bad brand image to the company. So hence it is very important that you're going to ensure that you're going to provide a value without any compromise on all these parameters. That's why we are here today. And this is very much important slide. Look at this carefully. Value is created by choice. Okay, choices. Okay, value is always by a choice, not by chance. It's not by chance. It's not just a chance alone. It's again a choices. And always note that the choice is always a best choice, best better choice. Okay, and it is, and again the choice is being selected by the stakeholders, and they are responsible for creating the value. And who are all the stakeholders in an organization? Okay, and the stakeholders will vary with respect to different perspective. For example, if you are going for company aspects, so you have different stakeholders, and if you are going for a different project, you may have different stakeholders. So let us concentrate on the organization which includes automobile or automotive application. So where you have different cross-functional team, starting from engineering, purchase, costing, sourcing, supply technical assistance, quality suppliers, consultants, and again the voice of customer. Even the customer is also a part of a cross-functional team. So you need to provide the value with the help of these stakeholders by choices. That choices is the best choice, and they are going to ensure that they are going to meet the choice is based on the quality, cost, performance, and planning. Without compromise on all this quality, cost, performance, and planning, you are going to provide the value. So in short, we can call QCPP, and in some company they call QCPD. So it depends, QCDP, and again it depends on the company to company. But in general, for every each and every understanding, I'm just mentioning that quality, cost, performance, and planning. So all these parameters are very much essential when you're considering the choices with the help of the cross-functional team or the stakeholders in a company, so that they can provide the value for the particular product, projects, or process, or even services. Okay. So many have known this topic, value methodology, but mostly you might be knowing value engineering. So that's why I given the title itself as value engineering in automotive application. This value methodology is slightly one step ahead of value engineering. It involves a different systematic approach. I will explain about that. So let me explain. No audio.
No, audio is clear, sir. You can continue, sir, please.
Okay.
Can you check your system audio, sir, please?
I need to increase my system audio.
No. Arun, sir. Arun, sir,
Yeah.
you can continue, sir. You can continue, sir, please.
Okay. So what is value methodology? Okay, value methodology is defined as a systematic process used by a multidisciplinary team. So I told you have the cross-functional team. Okay, so this value methodology is defined as a systematic process which has been used by a multidisciplinary team to improve the value of a project, product, or process, or even services through the analysis of functions and resources. So here you are going to analyze the functions and also resource. So cost is a resource, okay? Cost, energy, time, space, all these are part of the resource, in which the major contribution of the resource is based on the cost. Okay, so here we are going to analyze the functions and the resources using the systematic approach by the multidisciplinary team to improve the value. And this value methodology process uses techniques that enables the team to provide highest value to the product, project, or processes to serve the customer. So today the topic is value engineering. Okay. So what is value engineering? When you are applying the value methodology to a new product, projects, or processes, then it is called value engineering. When you apply the value methodology to the existing applications such as manufacturing goods or projects, then it is called value analysis. Okay. So this value methodology can be either value analysis or value engineering. And you can also call value engineering as value methodology and vice versa as well. But say, for example, I'll give easy understanding to you. If you take a vehicle, it can be a Tata or a Hyundai or Mahindra or a Ford. Let me take a Ford EcoSport vehicle for your understanding. So Ford EcoSport is already launched in the market. Suppose if you do the value methodology for the Ford EcoSport and when you apply the value methodology for the existing product, this is already in use. Okay, it is already existing in market. So when you do the value methodology for the existing product, then it is called value analysis. So let me give another example of a value engineering. If in case if the company is going to launch a product in the year April 2021, then when you apply the value methodology for the new product or a project or processes which is going to get launched maybe by next year or 6 months down the line, then that is termed as a value engineering. Okay. And you can use this value methodology, value engineering, and value analysis as interchangeably with each other. And always remember that value methodology is a quite common name, which can be used either for value analysis or value engineering. But there is a difference between value engineering and value analysis. And today I'm going to give some of the case studies, which includes not only value engineering but also value analysis. Okay. Um, okay. And this is very much important. I will tell what is value methodology is not all about first. And many would have thought that during the start of the session, many would have gone into your mind that value methodology is a process of cost cutting exercise. No, it is not at all a cost cutting exercise. And again, in fact, value is again, it's not a quality reduction process. It's in fact, we are also going to increase the quality through value. And I told you the first slide, value, we have to create a value without any compromise on the quality also. And value methodology is not a process which can be applied without the top management support. You need to have the top management support to achieve the value methodology. So this deep important thing you need to understand. Okay. So let me go to what is this value methodology is all about. It's a process to identify the unnecessary cost. Okay, if you this process will help you to identify the unnecessary cost and also the functions. Okay, unnecessary functions also you can identify using this value methodology. And this value methodology will help you to identify the potential performance improvements. And again, it will also help you to get some alternatives while assuring the quality, reliability, life cycle cost. What is called life cycle cost? Life cycle cost is nothing but the overall cost which are required to manufacture the product. Say, for example, it can be the labor cost, which includes indirect labor cost, and material cost, which includes direct material cost and indirect material cost, overhead expenses, uh, and and the miscellaneous cost also included in the part of life cycle cost. And here, the very important thing is that you need to meet the customer expectation, and also you should also try to exceed the customer expectations. In many cases, even though if you are not exceeding the customer expectation, at least you have to meet the expectation. Okay, and this value methodology will help to achieve to meet the customer expectations. And coming back to the value methodology history, this value methodology has been started during the World War II, and in which Mr. Lawrence D. Miles, he is said to be the father of value engineering and also the father of value analysis. And according to him, the customer wants a function. Okay, what the customer really wants is a function. People, and again, people want a function; they do not want the things. Okay, what 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 is the use when you're purchasing a vehicle which is not having a engine and transmission? Okay, so you can consider the vehicle as a thing, but the vehicle needs to have some function. Okay, basically it's used for a mobility purpose. It needs to have all the required parts for its mobility. So the people want the function, not the things. So this is very much important. And he is said to be the father of value methodology. According to him, the function analysis is very much important. So that's why even the definition of value methodology itself says that you are going to use the cross-functional team to achieve the value through the analysis of functions and resources. Okay. So according to Mr. Lawrence D. Miles, he stated that the customer wants a function and for which the company needs to do analysis, and that analysis is nothing but function analysis. And this function analysis is said to be the heart of the value methodology so that you can achieve the value through the particular product, processes, or a project, or even services. And in the name of Lawrence D. Miles, there is a foundation called Miles Value Foundation, which is helping for education, innovation, and also advocation. So this is the corresponding website. I will show you this website maybe by end of my presentation. I am also the education committee member in this Miles Valley Foundation. I will show this website after my session is after my presentation is over. there is another society called Society of American Value Engineering, shortly called as SAVE International. I will also explain about this SAVE International after my presentation. And this is spread across 40 countries, and it's having different membership. Uh, okay. So, coming back to the there even this SAVE International called Society of American Value Engineers. They are also offering a certification program called Value Methodology Associate Certification. What is the advantage of this certification is that this helps for a career advancement in your own company and also in other companies. And there is always an opportunity for the engineers to become a value engineering lead and also a program manager. And again, this value engineering is applied in all sectors. It's not only restricted to automobile or aerospace. It can be applied in all sectors. And hence, the certified value engineers are required. And this is the corresponding website link that I will tell you when I'm explaining about the website of Society of American Value Engineering. I am a course instructor for this Value Methodology Associate Certification Program. And I am one among 14 in India as certified as a certified value specialist. And I am a trainer for this certification program to many companies and also to many of the organizations. Okay, coming back to the topic of today, where this value methodology can be applied, especially in automobile sectors. This can be applied in all the companies. Okay, it's not restricted to one particular OEM alone. So when I say OEMs, it includes light duty manufacturer, heavy duty manufacturers, and also the construction or of highway equipments. And it also the value methodology can also be applied to their own companies, which supplies the parts to a OEM. And even this can be applied in tier 2 companies, which supplies the parts or components to their own companies. And this is value methodology can also be applied in service centers. This can be applied in public sector companies related to automobile, government companies, startup business, and also the research organizations. So we have a lot of wide applications where this value methodology has been applied in the automobile sectors. Coming back to the main area, the focus area where this value methodology has been applied is with respect to the automobile is the alternate source of energy, emission reduction technologies, hybrid and vehicle safety technologies. So now electric vehicle technology is getting an edge, and this value methodology has been applied in electric vehicle applications as well. And start-stop regeneration technologies even this can be applied. And mostly people are going with the weight reduction technologies for which we are going to use this value methodology approach. And vehicle comfort, basically suspension point of view, and even the people are going with a lot of alternate materials which will have lightweight and also high strength. At the same time, the cost is also going to be lesser without affecting the functions. And vehicle dynamics, automatic transmission, autonomous and driverless vehicle technologies. This is quite interesting, and this value methodology has also proven in the autonomous and driverless technology with respect to the automobile application as well. And this can also be applied in automotive electrical electronics systems as well, and vehicle frames, chassis, body structures, etc. So almost in all applications of automobile, this has been used. There is no area left behind which this value methodology cannot be used. So why we need to use this value methodology? We need to use this value methodology to save time, to save money. Save money is nothing but a resource, and time is also a resource. Okay, and in fact, you are also going to improve the quality. At the same time, you are also going to satisfy the customer. All these are been possible with the help of a cross-functional team, and that is possible by building the proper teamwork. So when you're using the value methodology, you are going to get all these advantages. The advantage here is you are going to save the resource. The resource is nothing but the time, money, and you are also going to improve the quality, which is nothing but a function. And this is possible with the help of a cross-functional team or a stakeholders. That is possible with the help of teamwork. And finally, what you're going to do is that you're going to satisfy your customer. So that's why you're going to use this value methodology. You have a lot of values. Okay, you have social value, political value, economic value, social value, judicial value. But as far as the engineering application is concerned, the economic value is very much important. And this economic value is having four type of values, which this value methodology is mostly concerned is been dealing with. First one is the cost value. What is the cost of the particular product or a process or a projects or services? That value you call it as a cost value. And the exchange value is nothing but, say for example, if you are exchanging the vehicle after 5 years or after 3 lakh kilometer of usage, what is the exchange value you are going to get for the particular vehicle? Say for example, if you are buying the vehicle for 8 lakh rupees after 5 years or after 3 lakh kilometer, what is the exchange value I'm going to get for the particular vehicle? And the esteem value. This esteem value is again quite not been esteem value is not been applied by all customers, but some customers need esteem value, some do not need esteem value. And say for example, if the Audi or Benz or BMW or Lamborghini, the customer who is buying those vehicles, they look into mostly of the esteem value for product. At the same time, when you're going for a low cost vehicle, some they do not want to have the esteem value for the product, but at the same time, they want to have the cost value for the product or the exchange value for the product or even the use value for the product. What is called use value? Use value is nothing but when you're buying a vehicle, what is the value that I'm going to get during the usage? Say for example, the vehicle they told you're going to use for 5 years for 3 lakh kilometer. During the particular warranty period or during the particular usage of the particular vehicle. So it should have the use value, or I can say during its operations or during its usage, there should not be any issue or there should not be any failure with respect to the vehicle point of view during the operations of for 3 years or so. But there may be some of the failures which can be minor, but the failure should get resolved immediately with the help of the service or whatever it is. But the failure or the issue should not prolong uh, during the working condition. Say for example, if you have an issue with respect to brake, or if you have the issue with respect to your steering system, it should get resolved with the help of the service center or with the help of the technicians. And if in case, even with the help of technicians or technologists or a service center, even if you're not able to resolve the issue and if you're running the vehicle with the issue for 3 lakh kilometers, then you do not have the use value for the particular vehicle. So here there can be failure. Obviously, there is no vehicle or no product will have 0% failure. There can be failure, but that should get resolved immediately, and it should function such a way the value when you what you are going to use during the course of operations should have its usage. Okay, so you have two type of value. One is desirable value, another one is undesirable value. So let me go to what is called desirable value. Value is defined as a ratio between function by resource, or I can say it's defined as a ratio between function by cost, because cost is a form of the resource. So I can increase the value by increasing the function which is highlighted in red, and the resource is highlighted in green. So I can increase the value by increasing the function. At the same time, by decreasing the cost, which is the ideal case. And you can also increase the value by reducing the cost or resource by keeping the same function. You can also increase the value by increasing the function at the same cost. Okay. The last one is I can also increase the resource. For example, I can increase the cost of the Tata Nano from 2.2 lakhs to 3 lakhs also. At the same time, I need to ensure that I'm going to increase the function. Say, for example, I can provide some of the ABS, anti-lock braking system. I can provide some additional features. Okay. So even though I'm increasing the cost, still I'm going to increase function of the particular vehicle. Okay. Even the riding comfort I can improve by increasing the cost of the vehicle from 2.2 to 3.3 lakhs. Okay. So many of you would have thought that the value improvement is only considering the first two cases. It is not like that. So even you can increase the function with the same cost. Okay. Even you can also increase the function of Tata Nano with the same 2.2 lakhs. Even you can provide some additional features to increase the riding comfort. Maybe you can provide with some better suspensions. Same 2.2 lakhs, it is possible. Okay. So here you're going to increase the function with the same function. Okay. Uh, Sorry, with the same cost or with the same resource, you're going to increase the function. Basically, the function here is the ride comfort. It's one of the function. Or you can also increase the value by increasing the function to a greater extent with respect to the cost what you're going to increase. So all these four categories comes under a desirable value. You have undesirable value which is not acceptable. So this undesirable value is always quite a reverse one to the top of a desirable value. You look at the last category, nothing but cheapening the product. So what many do is that many company what they think about value is that they want to reduce the cost. At the same time, they are also going to reduce the function. Say for example, if the cost of data nano is 2.2 lakhs, okay. So instead of 2.2 lakhs, if the OEM is trying to reduce from 2.2 to 1.5 lakhs, at the same time, if they reduce the function, which is nothing but a cost cheapening the product, okay, this is undesirable because I told you you're going to achieve the value without any compromise on the quality, safety, the norms. All these are very much important. So obviously, you can reduce the cost. I know about what Tata is a very good company, but just for an example, I have told. Uh, and when you're trying to reduce the cost, at the same time, when you're reducing the function to the greater extent, you are going to reduce the quality as well. At the same time, you are also going to reduce the safety as well. So in such case, you should not encourage this type of undesirable value. Okay. So I will just give another example, even with respect to Tata Nano. Tata Nano is a perfect vehicle. Okay, which when it launched in the market, okay, it is having all the functions. Okay, and the cost also less. Okay, it satisfies the first case. Okay, and again when it launched, even they also done a lot of value analysis, value methodology proposals, such a way till they have also reduced the cost. At the same time, they do not compromise on the functions. Even when the material cost, even the aluminum cost or the cast iron cost or the plastic parts, the cost when it is getting increased, even by the time they had satisfied these two conditions as well. Okay. So the vehicles would have all this consideration when you are going for a value methodology improvement. for a particular company. And that is possible not only with the help of OEM alone, but that is possible with the help of tier one companies and also tier two companies as well. Only if the tier one companies achieve the value methodology, the OEM can achieve. And once if OEM can achieve, they can satisfy the customer. So it should start from the resource. It should start from the point tier two to tier one to OEM. Okay. So who is responsible for value in a company? It's not the particular stakeholders alone. Even the stakeholders who is supplying the part is also responsible for increasing the value. Okay. So let me go to the function. Okay. You know all about the cost, but function is very much important. So what is called a function? Function is nothing but the intent or a purpose that a product, process, facility, or system or service is expected to perform, such that it will meet the need and want of the user, what the user really want, and what the customer or what the user need. You need to satisfy that, and you should also make that particular item or service to work as well as sell. Say for example, when you're buying the brake from your companies like Brake India Limited, so what the OEMs like Tata, Mahindra, or Ford, or Nissan, what they will look into the particular brake is that they will look that the brake will meet the want of the user, as well as the brake will meet the need of the user. The user here is nothing but a customer, and also they will see that that particular brake will work properly. At the same time, when you are selling the brake, okay, so when you are selling the brake, it should also you should ensure that the brake can also be saleable. Say for example, I told you the exchange value, okay. So after particular usage of the vehicle, you can also exchange the vehicle, okay. So you're also going to sell, okay, sell, basically you're going to sell it. So when you're considering the function, you should also ensure that the particular product what you're going to purchase should meet the need, want of the user. At the same time, it should work. At the same time, the particular product should also be made to sell after particular usage of time as well. And here you can apply this function to all the products, process, system, service, projects, etc. And here you need to satisfy the customer without any compromise on performance, reliability, quality, durability. And here the very important thing is that you need to ask the question, key question. The key question here is what does it do? What does the brake do? What does the clutch do? What does the steering do? What does the suspension do? What does the wheel do? What does the tire do? What does the axle do? What does the transmission do? What does the gear do? What does the propeller shaft does? What does it do? Okay, that is the key question that you need to ask. So there are some facts about function. Function is nothing but what the customer is buying. You need to understand what function does the customer want and need. What functions are not appreciated or not required. Okay, you need to provide a function that are not appreciated or required by the customer. So you need to understand the customer requirement in a very strategical manner. And what cost-effective ways can the particular company provide the functions? That is very much important. So I told you about value engineering and value analysis. So value engineering is the one you are going to apply the value methodology for the new products. So your new product normally starts with a concept phase, and next you go with the design phase. Then you go for a production launch. It can be a pilot project, pilot production, or it can be a batch production, or it can be a continuous production. After that, you are going for a improvement. So when you're applying the value methodology for a new product, for an existing product or a project, then it is called as a value analysis. For a new product, you call that as a value engineering. When you're going for a value engineering, you can save. You have a lot of potential to save, basically 20 to 30%. But when you're going for a value analysis, you have only few potential cost saving. And the one advantage with respect to the automobile is that volume is too high. Okay, you can take any OEM. Okay, all the OEMs the volumes are going to be higher, And when you save even 3% or 1% cost for one vehicle, the volume, say for example, if the particular vehicle is having 10,000 quantity in a month, you can have a very good saving. Okay. And again, in a year, you can calculate how much it is saving. So it is always advisable as far as the automobile is concerned. What this value analysis and value engineering is going to give you or is going to fetch you a lot of potential saving, and this also helps you to satisfy your customer. When you reduce the cost to your product, even you can also reduce the overall cost when you're selling the product. And again, you also have the challenges with respect to the material price increasing, like day by day, the price is also getting fluctuated. So the challenges you need to meet, and you should also meet your competitor price. So for all this, the only solution is value methodology is only solution. And I normally stretch more on value engineering rather than value analysis. But as far as this automobile is concerned, I always stretch both value analysis and value engineering equally. I also stretch more on value analysis as far as automobile is concerned, because I told you the volume is going to be higher. But when the volume is going to be lesser, apart from automobile sector, okay, there are a lot of sectors which includes like you can take machineries for example, heavy industries for example. uh, Irrespective of the quantity, if you have less quantity, then the value engineering is better than value analysis. But as far as this automobile sector is concerned, I always prefer both value analysis and value engineering equally. uh, Again, I told you, when you are applying the value engineering for a new product, it starts with the concept. You have a huge potential net saving. But when the number of stages is getting increased, the potential cost saving of through the value engineering gets reduced. At the same time, the implementation cost is also going to get increased. Okay. The implementation cost is basically the validation cost. You need to validate it. Okay. So suppose if you are changing the material from aluminum to plastic, or calcium to aluminum, or uh, material, when you're changing the material from X to Y or Y to Z, or when you're changing the supplier uh, from one company to another company. So you need to validate it. While you are doing a validation, you need to go for some testing, for which you need to spend some money. Uh, that's why it is always good when you are testing and you're implementing the cost saving proposal at the start of the projects. The implementation cost will be lesser, but when you are implementing any new ideas after production, you need to do a lot of validation, for which you need to spend some money for for the validation cost. And even you also need to do a lot of design verification plan. Say for example, you also need to do some of the tests like vibration test, temperature test, for which you need to say pay some money, and durability test. And that's why it's always value engineering is better than value analysis. And it's always best when the volume is lesser. It's best to go with the value engineering. And when you have huge volume like automobile, even after production, and you can also look for the cost reduction proposals. So this is the complete framework that we are going to see today. We are going to start. I am going to give you two case studies in which I will be covering phases, which includes the pre-workshop phase, which is nothing but the orientation phase, where the company will select the project and they will do underground basic information about the product what they have taken for a study. And the next important thing is the workshop phase, where they collect, where they have six phases. First is the information phase, where they go in to collect all the information about the product. It can be uh, the information with respect to the product, bill of material, cost involved for the particular product, what is the material being involved, what is the manufacturing process, who are all the competitor for the same product, what is the cost of the competitor, or what is the benchmark that they have, and all the information you're going to go with respect to a particular product in a micro level. Function phase. So I told you the function is the heart of the value methodology. So here you are going to analyze the function. So the function is nothing but what does it do? Okay. So I given an example, or I given you an overview about function. So all these things we are going to apply here in the case of function phase about the particular product. Next, we are going for a creativity phase where we are going to create ideas or generate ideas using functions. Okay, it is not that we are directly jumping to the creativity phase on seeing the product. So we are going to go with the functions of the particular product. Then we are going to create ideas considering the function. So next we are going to go with the creativity phase. After creativity phase, after creating new ideas to improve the value, we are going for an evaluation phase where we evaluate the ideas, which based on the evaluation we try to get, and that best idea will be taken for development, where even the testing happens, and we also do all the design verification plan, testing, validation to ensure that there is no failure going to happen for the particular ideas. Then we go to the presentation phase to the top management. And after we present the ideas to the top management, then we implement the ideas. Then we also do the follow-up. Follow-up or audit phase. So follow-up here is nothing but, say for example, when I am changing the material of a engine cylinder block from cast iron to aluminum. Okay. Even after completion of all the validation, I also need to follow up in the field that there is no failure is going to happen at the field. Say for example, they should also do some survey out of 1,000 vehicle or out of 10,000 vehicle. What is the failure rate with respect to the new ideas, whatever you taken or implemented through this value methodology approach? You also need to follow. At the same time, you also need to audit. You need to document it such a way what's the cost saving, what's the cost involved for the project. So all this you need to audit it and also you need to document it. So this is the framework for the value methodology that we need to go step by step. So first is the pre-workshop phase, next is the workshop phase, next is the post-workshop phase. So this is a step-by-step approach which involves functions, and it also involves creativity or innovation. And this innovation is through function. Okay, it is not that by looking at the brake, by looking at the suspension, by looking at the axle, by looking at the differential, by looking at the engine, by looking at the transmission gears, shaft, I'm going for the ideas. Okay. So I need to look at the function of each and every product. Then I need to create ideas. I will give you some of the example you will understand. Okay. So this value methodology is having 4 pillars. A step-by-step approach. So this is a step-by-step approach. It involves multidisciplinary. It's again a function-oriented, and it involves creativity and innovation. And this innovation is through functions. Okay. Okay. I will just touch upon the manufacturing also. This value improvement is also possible in supply chain and also in manufacturing aspects for automobile application. But I'm going to give you some of the case studies with respect to products. Okay. I'm not going to give you too much on processes or projects or services, but this can be applied even to the sector as well. If you are from a project background, or if you are from process background, or if you are from service background, please do let me know. I can give you an overview even for that as well. This is a block diagram how this value methodology can be applied in a manufacturing company or in a supply chain process. So here the company should get all the available cost, and they should get the information from the best source, and they should not get the details in general. They should go for a in-depth information. They should get the in-depth knowledge. They should get the in-depth information about all the things that are involved when you're going for a supply chain or a manufacturing process. Then the company should go for a brainstorming session. They should collect as much ideas considering the function. So here the brainstorming involves the blasting the ideas, creating the ideas, refining the ideas, then the company should identify and they should understand what is the roadblock to implement the ideas. They should identify and they should overcome the roadblocks. Then they should go for expertise, expert knowledge, and say for example, when you're going for a manufacturing process, sometimes the tolerance can be an issue. Okay, so you need to understand whether the tolerance issue can be resolved or not. And if in case if you want to achieve a particular tolerance, you also need to pay the money to the vendor or the contractors. You need to understand all this thing and what is the cost involved. You need to understand, and finally, you need to understand the synergy to achieve the cost reduction in the supply chain process. Supply chain normally starts with the raw material in to the raw material or the finished product going to the customer end. So here you need to understand what is the objective here is. Objective in any company is that you need to reduce the costs with respect to the supply chain. At the same time, the production functions would get improved. Basically, the productivity should be higher. So this value engineering can be applied even in the production department, in manufacturing department, and also in the supply chain process as well. I told you are going to start the thing with respect to the information phase. The first is information phase, in which this is an example of a product. Basically, if you know going for any localization, you can analyze using these parameters. First, you need to identify the strength, weakness, opportunities, and threat. What is the strength of your company, weakness of your company, what's the opportunity you have, what's the threat you have when you're going for a localization. What is the financial leverage that you will have for manufacturing the product? So you should also have the benchmark on the technology for manufacturing. You should also get the voice of customer, bill of material. What is the material being used? Suppose if I am going to start my own company, which will be manufacturing brake, then what I have to do is that I need to identify my strength, my weakness, my opportunity, and my threat. I need to understand my financial leverage for manufacturing the brake. What is the benchmark uh, I have with respect to the brake technology for manufacturing? So I need to understand all these things. So what is the requirement? What is the requirement of Maruti company? What is the requirement of Nissan? What is the requirement of Renault? What is the requirement of Mahindra? I need to understand the customer requirement. So whether they have specific requirement or not. I should also understand the bill of material for the brakes. Okay, the brake have drum brake, disc brake, and again you have different parts involved in the brakes. It can be caliper, you have pad, you have brake shoe, brake drum. So I need to understand in depth about the bill of material, and also I should understand the commercial breakup. Okay, and what is the material being used for the particular brake and particular parts basically. And I should also try to collect the quality reports, the history report of the brake, and again what are who are all my competitors. Same thing you can use it for your company as well. And how I can manufacture the brake. That manufacturing process is very important. And I should get all the drawings, product specification. If I need some FEA, all the design aspects, you need to get it. And the process flow diagram is very much important. Specification is very much important, and quality control plan. So even you can apply this even for your existing product also. Okay. Suppose if you are working in a company in India Limited, even you can apply this one as well. Even if you want to start manufacturing the brake completely new, even you can apply this value methodology. Or if you want to launch a new brake for a new customer in the year April 2021, then you can apply this value engineering as well. So this framework can be applied in a number of ways. And you need to get the DVP plan. What are all the DVP is required for me to execute a brake without any failure? DFMA I need to get, DFMA I need to get. I need to understand the time study. I need to understand the process time, cycle time. And I should also get the detailed flow chart. And I need to understand what is a functional product and also what is the non-functional product. What is the functional area and also non-functional area. All this I need to go in depth and I need to analyze it. Then what is the cost that the competitor is giving for the brake, and what is the final cost driver for the project as well. So all these things you need to get a framework when you're going for information phase. Okay. This is just the matrix, which is called as the cost ranking matrix. So I told you resource. When you're reducing resource, you can also increase the value. Okay. So here the cost ranking matrix. So here I'm going to divide into four category: A category, B category, C category, and D category. A category is the category which comes under the ideas. The A is nothing but a list of ideas, okay, which are very easy to implement. And again, the cost savings is also going to be higher. Say, for example, when I'm changing the material of the cylinder block from cast iron to aluminum, okay, um, what it can be easy, the ideas can be easy to implement, or sometimes it may be hard to implement, okay. So I need to identify whether it is easy to implement or hard to implement. But definitely you are going to get huge cost saving because you are going to reduce the weight. Or at the same time, I will take another simple example for you. I'm going to convert the aluminum manifold into a plastic manifold. Okay, so aluminum AL SiCu3 material I'm going to convert to plastic amide PA6 with glass fiber of 30%. You are going to reduce the weight. At the same time, the cost saving is also going to be higher. Okay, you can categorize that in A category where it is easy to implement and the cost saving will be higher. And B is the idea which is hard to implement, but again the cost saving will be higher. There can be even you can take the example of a suspension or a brake. Suppose if you are changing some of the friction material, sometimes it may be hard to implement because you need to do a lot of testing, you need to do a lot of validation. It may take some time. Okay, it may be, but if you implement that, you have the last lot of huge cost saving. But the implementation will be slightly hard, but cost saving is going to be higher. And C category is the one which is difficult to implement, and at the same time, the cost saving is also uh, going to be lesser. Cost saving can be higher. Say, for example, uh, uh, the difficulty level can be higher, but at the same time, uh, the cost saving can be low. At the same time, when you can consider D category, I am going to categorize the ideas which is very difficult to implement. At the same time, the cost saving is also going to be lower. So normally people will not go with the D category. Sometimes even they will not go with the C category also. But the C category will go because you have a considerable cost saving. Cost saving is slightly higher when comparing to the D category. But the difficulty level is too high for a D when compared to C. People normally go with A category and B category, but still they will, even as I said, the value analysis, even a small cost saving will have a huge potential when you have a huge volumes. So considering the volume, people is still they go with the C category also, even though it is difficult to implement and even though the cost saving is also lesser. Even this cost ranking matrix can also be applied in a different way, like A, B, C, D, E, F. Uh, so here A is the idea which is having high cost saving, which is applied for a running change, which is already in use by changing the diameter, by changing the thickness, by changing the material, by changing the optimization, by changing the optimization of the design. So this for a running product, if you do any cost saving, you can do it high saving as well as the low savings. You can also do the digit change. Digit change in the sense that the thickness reduction, height reduction, or width reduction. And again, for a new model, also you can go with the cost ranking matrix, high savings as well as low savings. This year to F just for easy purpose, I have given the you can use as per your convenient, as per your company norms. Next, finally, you have to go for a business case, which involves because you are going to do the testing, which involves the tooling cost, development and validation cost. So you need to understand what is the total cost for implementation. What is the cost saving that you're going to get for one particular product? Then, with respect to the volumes, you can also understand what is the overall volume that you have for a year, and what is the overall saving that you can get it when you're going for this value methodology approach. You can also calculate the return on investment or ROI, and you can also present to the top management that you are going to get the ROI, whatever the money you are going to invest, that you can get it in 3 months' time or 6 months' time. You can present it to the top management, and basically, if you are going for a localization, this business case can be applied, but this template can be applied in a much more better manner. Okay, so when you're going for a framework of any idea generation, you need to eliminate the ideas. You need
అన్నా
to reduce.
సౌండ్ రావట్లేదేంటి? సౌండ్ రావట్లేదేంటి?
Okay, so you need to eliminate the ideas. You need to reduce the ideas. You can also modify the ideas. See, when I say the framework, so you can do the chain optimization. You can also do the optimization with respect to your specification, route and stack up. You need to identify the functional analysis, functional area, then you have to go for this. Then you can also go for a alternate material or a component, or you can also go for some the value improvement by raising some of the functions. And here you can also create some of the ideas which will help for design for optimization. At the same time, what is the focus here is the focus here at this point of time is mostly on optimization with respect to design, specification, and alternate material. So this is the need of an hour at this point of time. So we need to look for elimination, reduction, at the same time modification. So these three things will help for better cost saving, at the same time a value improvement as well. So you need to look for some substitute. Say for example, in autonomous vehicle, you have artificial intelligence instead of human intelligence. Okay, even I'm also studying software that going for a value methodology. Even the ideas can be generated with the help of this artificial intelligence and machine learning as well. So you don't need to have the human interference. Okay, so I am also looking for some substitute. Okay, uh, so you can also go for some substitute. You can also go for some rearrange, like uh, you have some of the electric uh, wheelchair. Okay, so when you're going for even this electric wheelchair can be affordable one. Okay, and sometimes I can also eliminate some of the things. So like say for example, I'm going for a 360-degree turn instead of a reverse gear. Okay, just this is just a third process, and I can also combine, like see, this is the one of the vehicle having both vehicle application and car application at the same time. It is also having the scooter application. You see, and I can also adapt some of the technologies like vehicle plus bird wings. This is slightly away from the topic, but this will help you to go to the deeper understanding how what are the ways. Even you can also modify it. You see here the wheelchair ramp from the rear vehicle. Okay, it looks like a wheelchair. Okay, and again you also have the solar vehicle, solar electric vehicle also, where you have the solar panel at the top. So you can apply this idea generation as far as automobile is concerned in any number of ways. But what the focus is today here is we are mostly concentrating on the design optimization, specification optimization, at the same time the material optimization. uh, there are many ways how we can achieve the variability. So the first one is by localization of the product, processes, or services or projects by changing the supplier. Say for example, if you're changing the piston supplier from Federal Mogul to Borgon, Sri Lanka pistons or India pistons. So when you're changing the supplier, there is always a cost saving will be there. Function improvement also you should look into it. If you're changing the material, also you can achieve by changing the material, you can achieve the value methodology. By doing optimization, you can achieve the value methodology. And again, make or buy decision. Okay, so whether you want to buy or buy make. Say for example, the crankshaft machining or camshaft machining or cylinder block machining. some companies they do it at a supplier end. Some company they have their own machining plant, their own OEMs they have. Okay, so they will do the machining of a cylinder block or a crankshaft. So sometimes they feel that the cost reduction can be much more higher when they make in their own company. Sometimes they feel that when they're paying it, the cost saving is better. At the same time, the quality is also going to be higher. When they think it that way, they can also go for this make or buy decision analysis. And we can achieve the value methodology by the idea categorization as easy and difficult to implement with high to low savings. So that's what I told in the A, B, C, D category. So the ideas can also come from designers to tolerance stack-up. The ideas can also come from suppliers. The ideas coming from experts, consultants. The ideas can also come from the voice of customer. So you might be working in a company's related to OEM. So I have seen some of you are from JD, John Deere also. So you can also, in fact, you can also get you can also give you being the customer to tier one, you can give your ideas to your supplier, and in fact they can achieve the value by getting the ideas from your company. And in fact they will help you to get their value, because the ideas what you're going to get, they're going to implement it and they're going to supply a particular part or product to you, in which that will help you to achieve the value improvement. And when you achieve a value improvement, your end customer is going to get a value. And even ideas can come from the top management with respect to project process or services. Ideas coming from the failure. Sometimes there can be some failure, and if you resolve the failure, you are going to increase the value. And you can also increase the value by getting the ideas from the quality team, purchase team, costing team. The purchase will have a lot of different suppliers in their mind. They will give some ideas, and even the ideas can come from the service team, warranty team. The ideas can also come through the workshop involving brainstorming. So whenever you conduct any training program or a workshop, you involve the cross-functional team where you go for idea generation, and that will help you for a value methodology. So whenever you're going for any idea generation, you should always use the functions. Okay, but most of the workshop, whatever we are doing, we are not going for a function analysis. Rather, we are going for directly we are jumping to the brainstorming. So the idea behind this value methodology is that you need to use the function for the idea generation. So you need to understand the volume, return on investment, payback period, break-even analysis. So you should also analyze your over engineering. If it is not required, then you should downsize, or you should reduce the. You need to do the optimization. Then benchmark analysis is very much important. Tier down analysis is very much important, where you get a lot of ideas how you can reduce the cost. The re-engineering, reverse engineering, to cost analysis, all this will help you to achieve the value methodology. All these have been possible if you achieve the value methodology approach using function analysis. So these are all the different ways where you can achieve the value methodology, but always look at the functions. Okay, this is the key. Function is the heart of value methodology. When you achieve the functions, you can understand how in what ways you can reduce the cost, or you can increase the function, or you can achieve the function. Okay, so always consider this function analysis whenever you're going for a value methodology. Okay, so now we are going for a practical thing now. A lot of examples of give. So how to identify a function? I told you function is nothing but what does it do. So you should have one verb and one measurable noun, one active verb and one measurable noun, and this will help you to. You're going to go for an innovation or creativity using function. So you should have a very simple two words. One should be a verb and another one should be a noun. One should be active verb and another one should be a measurable noun. So what is the function of a motor? The function of a motor is to convert energy. Convert is a measurable active verb and energy is a measurable noun. What is the function of transmission? Transmission transfers torque. What is the function of a pump? It can be oil pump or a water pump or a or a hydraulic pump, whatever. Then what is the function of a pump? The function of a pump is to generate pressure. Okay. So here, when you're going for a function phase, you need to ask the question: what are the key function of the particular product? So you need to identify the basic function and secondary function, and you should understand. You should ask the key question: what are all the different key function worth? Okay, you should understand what's the worth and what's the cost also, and which functions can be eliminated and combined. Sometimes two functions can be eliminated. Sorry, two functions can be combined. Sometimes some functions can be eliminated. You need to identify. And the technique here is the unnecessary and concurrent functions can be eliminated. And understand what functions is having the poor value. You can eliminate that particular function which is having the poor value. And as I said, you should also look for the optimization of the design and drawing tolerances. So in the function phase, you need to do some task which involves random function is, I will tell you what's the random function. Then you need to classify the function into basic function and secondary function. And you need to classify the function. Then you need to go for a fast diagram called function analysis systematic technique diagram. And you need to analyze the cost worth relationship for each and the individual function. Then you need to complete the cost function worksheet in the function phase. Okay, this is the template that normally we have for a function analysis, random function analysis. So here you need to write down the component name. Suppose the brake is having a brake pad, caliper. You need to list down all the component name, basically bill of material, and what is the cost involved for the bill of material. Then you need to list down all the functions randomly, uh, basically basic function and secondary function using verb and noun combination. This is the template. Then you need to allocate what is the cost percentage, what is the cost involved for a particular individual functions. Okay, and what is the value? What is the function cost value? You need to put. This is just a normal template that you have. Uh, this is the example of a gearbox. Gearbox is having lot of parts. I have taken only 3 parts, having housing, gears, and shaft. This is just a example. This I have used it for training purpose. The housing, the component in the housing of a gearbox is having a cost of 3,213, and which contributes to 48% of the overall cost of these three. And gears is having 1,714 rupees, and shaft is having 727. Okay. So first I need to understand which is the highest cost contributing factor, and you need to list down. Okay, and we should list down all the parts that are involved in the gearbox. So here I have taken only just 3, just for a training purpose or just for understanding purpose to explain to you. So what is the function? What are all the functions of a gearbox housing? Okay, the basic function of a gearbox housing is to protect component. Gearbox housing is having a inside the housing, it is having a lot of components like gears, shafts, etc. So what is the basic function of a housing? The basic function of a gearbox housing is to protect components. One verb and one noun. You have different functions of a housing. It should meet specification, it should withstand vibration, it should maintain integrity, it should resist corrosion, it should maintain strength, it should ensure reliability, durability, safety, appearance. It should also connect components. Even the housing, it should identify brand. Who is the supplier for the housing? Okay. For that, it should identify the brand. It should also prevent leakage. It should withstand load. It will also receive force. It should also withstand resist environment. It should meet standards. So you need to list down all the functions of a gearbox. Sorry, all the function of a housing, which is a part of a gearbox. And next is the gears. What is the basic function of a gear? The basic function of a gear is to transmit power. So, and you have different functions apart from transmitting power. It transmit torque, it generate rotation, it ensure reliability. So you need to list down other functions of the gears. Similarly, the shaft. What is the basic function of a shaft? It transmit power. Apart, in addition to transmit power, it also transmit torque. You need to list down all the functions similar to what you have done for gears and housings. Okay, now you are going for a technique called fast diagram. It's nothing diagram. So whatever the functions you are randomly written in the random function, you need to put it in a structured manner called fast diagram. This is the fast diagram. It is having one left scope line and one right scope line. First, you need to list down what is the basic function of a part. What is the basic function of a gearbox? Okay, so gearbox may have housing, gears, and shaft, but here you need to list down the basic function of a gearbox alone. Okay, the basic function of a gearbox. Okay, and then what are all the secondary functions you need to list down? But you need to list down using how technique and why technique. When you go from the left scope line to the right scope line, you need to apply the how logic. And when you go from the right scope line to the left scope line, you need to apply the why logic. And these functions, what you're going to fill here, it should come from the random function. And I asked a question why to the basic function, it becomes higher order function. And lower order function is the least possible function is required to achieve the standard function and basic function. You have the project objective. These are all the functions that are required to achieve the project. And a one-time function, which involves the function which are required one time. Say, for example, ensure warranty. All these are one time. Or protecting the product. Say for example, if the brake or suspension, if it is coming from a tier 1 company to a OEM, basically the tier 1 company they are going to ensure you warranty at the same time. They are going to pack it in a more safer manner. They are going to protect the product and they are going to send it. So all these are one-time function. So all the time function involves a function which are required before you selling the product to the customer. Okay. The enhance appearance or ensure safety or reliability, durability. So all these are a few examples of all the time function. Let us go with the fast diagram for a gearbox. The basic function of a gearbox is to transmit power. Why to transmit power? When I ask the question why to the basic function, it becomes a higher order function. So why I need to transmit power to enhance appearance? So higher order function is the higher order function is enhance performance. The basic function of a gearbox is to transmit power. How to transmit power? By transmitting torque. How to transmit torque? By generating rotation. How to generate rotation? By transferring force. How to transfer force? By receiving force. How to receive force? By applying force. I'm going to apply force to the gears. The gear receive force. Why to receive force? To transfer force. Why to transfer force? To generate rotation. Why to generate? Why to it should transmit to increase my performance. So here you follow how logic and why logic. And this is a lower order function, this is a higher order function. And project objective indicates the objectives which involves meet specification, meeting standards, leakage, prevent leakage, providing strength, durability. So all these functions you need to list down here. And one-time function is, for example, ensure warranty. And all the time functions you need to list down all here. So here, what is the advantage of this is that so phase is nothing but a creativity phase where you are going to create ideas considering the function. So for example, for transmitting power, what are all the ways? Here, I'm going to create ideas considering the function. So this will help me to increase my number of ideas at the same time. I'm not going to compromise on the functions. Okay. So value is nothing but function by resource or function by cost. So cost is one aspect and the other aspect is function. And when you look at the functions, you are going to new ideas or generate new ideas using the functions. And next is nothing but a function cost worksheet. Okay, this is a bit difficult for you to understand this at this time because you have very limited time. I'll just give you an overview. So here I've taken an example of a gearbox having a housing, gears, and shaft. And housing is having a 57% of the overall cost. 30% of the cost goes to gears, and some 13% goes to shaft. And these are all the different functions that you have that you got from the first diagram. Okay, so now here what to do is that you need to allocate the cost for the individual functions. To receive force, you need to spend 36.6 rupees out of this 3,213 of the overall housing to achieve the function called receive force. To prevent leakage, I need to spend 54.9 rupees out of the overall cost. You need to for individual function, you need to allocate the cost, and this allocation is possible only if you have the support of your cross-functional team. Okay, so that's why you involve the costing team, sourcing team, purchase team, suppliers also, because suppliers will give you the correct data with respect to the cost. Okay, there can be some transparency will be there, and again this will help you to understand or eliminate the unnecessary cost. At the same time, this will help you to understand the functions which is contributing to the highest cost. Then what you can do is that you can understand the highest cost contributing function. Then you can create ideas for the highest cost contributing function. You don't need to you don't need to take all the functions for your idea. The top three functions or top four functions is contributing to the highest cost. Then you can go for idea generation for the particular functions. Idea generation can be the ideas what I told. You can use all these techniques for your idea generation, but all these techniques should be used considering the functions. Let me give the examples with respect to the fast diagram for some automotive components. Basic function of a vehicle leaf spring. The basic function of the leaf spring is to improve comfort. Why to improve comfort? To enhance drivability. So how to improve? When I ask the question why to the basic function, it becomes higher order function. So how to enhance drivability to improve comfort? How to improve comfort? By maintaining damping and also by absorbing shock. How to absorb shock and maintain damping by distributing load. How to distribute load by transferring force by applying force. So the force gets transferred to the leaf spring, vehicle leaf spring. So when you apply the force to the leaf spring, the force gets transferred and the load gets distributed. You are going to maintain damping at the same time. You are going to get shock absorption, and finally you are going to get the comfort, and that will help you to enhance the drivability. So you have left scope line and right scope line. The scope of the project always lies between these two. So when you're going for the function cost analysis worksheet, you need to take all the functions from the fast diagram between the left scope line and right scope line. You should avoid the higher order function and lower order function because this leaf spring function is to improve comfort. It is not to enhance drivability. Okay, when you improve comfort, be enhanced. Okay, and similarly, the function what you have to apply force. Okay, anyway, you are going to get a force when the vehicle is running, and but I'm not going to spend money to apply force. Okay, I'm going to spend money for transferring force to distributing for load. I'm going to spend money only for the functions which are there between the left scope line and right scope line. Okay, in order to get this fast diagram, you need to go for a random function analysis, which you need to it might take some time, but you need to go for a random functions where you need to identify all the functions And even you can also identify some of the unnecessary functions using this fast diagram. And the project objective here is to resist corrosion. It should withstand the leaf spring should withstand vibration. It should meet the specification. It should also maintain hardness. And all the time function, it should identify manufacturer. It should enhance aesthetics. It should ensure safety. At the same time, it should maintain reliability. Okay, let me go with the clutch. What is the basic function of a clutch? The function is to transmit torque. And the way to transmit torque, to transmit power, it's almost same. How to transmit torque to generate motion, how to generate motion by generating pressure, how to generate pressure by distributing load, by transferring force, by applying force. Okay, you know the synchronous ring in a transmission where the basic function is to match speed. Why you need to match speed to avoid slippage? The company is spending money only to match speed, not to avoid slippage, because the basic function of a synchronous ring is to match speed. The slippage gets avoided. How to match speed? By generating movement, by transferring torque, by distributing load, by maintaining position, by enabling rotation, by transferring force. Function of your crankshaft. Again, the basic function of your crankshaft is to transmit torque. Why to transmit torque? Develop power. Okay, this is the compressor, AC compressor in automotive vehicle. The basic function of a compressor is to condition air, comfort. How to condition air? By compressing fluid and also circulating air. And how to compress fluid? By generating pressure, by connecting circuit, by selecting mode, by applying force. Why I need to apply force? By selecting mode, to select mode, to connect circuit, convert energy, to generate pressure, to compress fluid, and also when I'm compressing fluid, I am also going to circulate the air, and finally I'm going to condition the air. So these are all the project objectives. You have one-time function, all-the-time function. Okay. Even for a so this is an example of a stamping process. The basic function of a overmold stamping is to overmold stamping process is to overmold stamping. Why to overmold stamping? To bond assembly. How to overmold stamping? By injecting plastic and also generating stamping process. So you have different functions. Follows how logic and why logic. So here the project objective is to verify the dimensions of the machines, maintain tooling, and also the durability. The process should be controlled. And all the time function can be maintain appearance. It should prevent injury. Okay. It also ensure reliability. It should also reduce scrap. So this is just an example of a process as well. This is the example of a fast diagram of a clutch housing. The basic function of a clutch housing is to sustain load. How to sustain load? By supporting object. How to support object? By ensuring the engagement, by assembling parts, by aligning parts, by transferring force. Do it for the different product or a different thing what you have for automobile. Let us go for some of the case studies. Using function, so I'm going to get this case studies. Okay, so this is the utility packet which has been replaced with injection molding. It basically the bottle holder. This is one of the bottle holder which was having the metal previously. That has been replaced with the help of a plastic component using injection molding. So this is a bottle holder. Nowadays you use this injection molding process. So you have the very good aesthetic thing. In olden days, you have the bottle holder of made up of either the sheet metal or a metal thing like where the weight is also going to be higher, the aesthetic is also not good, and even the cost saving is going to be lesser here. And this is an example of the value methodology. Before it looked like this, and after it looked like this. Before that, you have electric power assisted steering, and now you have through this value methodology, you are going for a hydraulic power assisted steering, and again the cost saving is going to be lesser. At the same time, you see here, you see it is not that the cost saving alone. Hydraulic power assist steering provided in space, it is provided in place of electric power steering. And here, both are achieving the same function. And performance criteria is also going to be same. But at the same time, the hydraulic assisted steering is going to have huge monetary benefit. Okay, but what is the function of your steering? Okay, it should steer as per the intention of the vehicle or the driver. Okay? Irrespective of the method, it can be either electric steering or hydraulic steering as well. But the cheapest way to achieve the function without any compromise on the quality or a performance or a function is that the hydraulic power assisted steering is the best way. And this is the value analysis that has been done in a vehicle door trim. So the whole trim is having the structure like this, and you see the structure of the whole trim, and you see the structure of the new trim having the armrest. Okay, and you see even the inner handle or the upper substrate. There is some aesthetic wise, there is an the improvement here, uh, and even you see even this is the switch bezel, and there is some modification which has been done, and even what the advantage what we have with respect to this is the cost saving is going to be higher. At the same time, the aesthetic is also going to be much more better with the help of the new door trim. And here the function is not going to get affected. At the same time, you are going to reduce the cost, and aesthetic is going to be higher. This is the clutch housing. I have given you a fast diagram. So here by analyzing the functions, so I'm going to reduce the weight. Okay, and it's not just I'm looking at the product. I'm going to reduce the weight, but here the weight reduction of 10% will help you reduce the cost as well. And again, the weight what you're going to reduce is not going to affect respect to the vibrations or other aspect as well. So here, what is important is you are going to create ideas or generate ideas considering the functions, not in generic things. Okay, so you need to look at the functions and then you create ideas. Okay, so this is the example of a sprocket having the case compressing one and also the induction hardening one. So when I'm going for a induction hardening rather than case compressing, my cost gets reduced. Okay, at the same time, my hardness and also the strength is going to be higher. So here I'm going to reduce the cost of manufacturing this sprocket by induction hardening rather than case compressing. At the same time, hardness is going to get increased. At the same time, my strength is also going to get increased. So here you have advantage where the value is getting increased by increasing the function at the same time by reducing the cost. This is one of the example which has been done in car roof rails. This is the assembly of the old roof rail of a car. So this is the modified one. Basically, this roof rail is used for aesthetic, not only for aesthetic, even to hold some of the weight or object, but mostly people use it for aesthetic purpose. So here, without affecting the function, there is some change of the raw material which will happen from this to here. At the same time, not only the aesthetics, but even the function gets remain same. So I told you this can be even applied for a manufacturing process. This is the connecting rod manufacturing process, which is before valley metallurgy, which is having a lot of stages. It includes fresh grading, boring, turning, slitting, milling, boring, again grinding, and then final inspection. So after this valley methodology, without affecting the function or without affecting the process of connecting rod, so the manufacturing process has been optimized, and here the cycle time of manufacturing gets reduced. And when you reduce the cycle time, you are going to reduce the manufacturing cost also. At the same time, here extra the process, extra machines which is there, uh, the process is also gets eliminated. So you have the better process. So you have lesser manufacturing cost. When you have a lesser manufacturing cost, your overall product, the life cycle cost gets reduced. This is one of the example of a heat shield. This is the localized heat shield. Is the localized heat shield. But the function of a heat shield is to protect. Okay. So here the exhaust gas is circulation. The function here is it's to protect the 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 product. Okay, when it is exposed to high temperature. Uh, so even the function here is to protect the easier wall. So even this the imported heat shield can be replaced with a localized heat shield. So when you're going for a localization, the cost gets reduced. At the same time, you need to ensure that the function is not going to get affected. Here, the function here is you need to protect the easier wall. Okay, so it gets protected. And this is the example of the accessory build type system in an automotive engine. This is the existing proposal. You have a layout, the AC pulley, you have the alternator pulley, you have the auto tensioner, and also the belt. So what happens during the development stages? So they have replaced auto tensioner with the idler, okay, and also they have gone for a stretched belt, okay, and this helps for cost reduction. At the same time, the performance is not going to get affected. So we are going to ensure that the performance is not going to get affected with the help of simulation, also some of the analysis. So you need to do all the validation, and also you also need to do the physical validation, and also you also need to do the establishing the process. You need to do the concept verification as well. Next very important thing is the variable valve timing. You know the function of a variable valve timing, which will help for reducing the emission. But this is one of the quite interesting thing. So I'm going to eliminate the exhaust variable valve timing, exhaust VVT. But you see, first I will tell you what are the advantages of eliminating this and how I'm going to achieve the function. The function of this VVT is to go for the emission reduction process. So I can also reduce the emission in various ways apart from having the VVT as well. And again, that is a very big, vast topic. You see how the value methodology is being applied for this particular VVT elimination. So you have the exhaust VVT, and that is been replaced with the help of camshaft pulley. You have the trigger wheel, you have the position sensor, you also have the solenoid valve when you're going for a VVT process. So all this solenoid valve, position sensor, and also trigger wheel gets eliminated when you're eliminating the VVT. And modified design is very simple and without affecting the function. There will be some drawback with respect to emission reduction. Emission will not get reduced when you're eliminating EVVT, but at the same time, I'm going to compensate that with the help of the other process, either go with after treatment or the lesser cost, the multiple injection strategies. There are many ways where I can reduce the emission, and I have I have found out the other ways, but I'm going to reduce the cost of this design. I told you about value, which is also defined as can be defined as a ratio between worth by cost. You know the cost, and what is called worth. Worth is nothing but the least minimum possible cost to achieve the function. Okay, to achieve the particular function of the particular product. And again, the worth can be dynamic because the worth is again a subjective one. But you need to consider the worth without any regard or criteria. So when you have the higher value greater than the one, it is said to be a good value. When the value is less than one, it is called a poor value. You also have the value index, value gap. Value gap is nothing but the difference between costs to worth. When you have higher value gap for your product, you should you should look for value improvement. And when you have a higher value index, which is defined as the ratio between function cost to the function worth, you need to go for value improvement. Higher the value gap, higher the value index, then value lesser than 1, you should always look for the idea generation. And this idea generation is possible through the creativity phase, where you are going to create ideas considering the function. Okay, so here you should always go for an innovation kind of thing. There is always a difference between innovation and creativity. Creativity is best generation of new ideas, whereas innovation is nothing but you're going to convert the ideas into a output. Okay, so whatever the case studies I have done, it's basically it's not only the ideas created, but also the ideas gets implemented. So when you implement ideas, it becomes innovation, and our objective should be from invention or from creativity to innovation. We should always look for innovation, but that is possible only with the help of creativity, and creativity is nothing but the generation of new ideas. And when you generate new ideas using functions, you go for a lot of new creativity. And you see here, innovation is nothing but it's not only it's not what is being seen by everyone, and it is nothing but what is not seen by someone that you need to see it, and you need to look such a way. You need to have some thought process, and you should think such a way that nobody would have thought. Okay, you need to go for that level of idea generation, but that can be possible if you go using functions. So this is a general template. So this is the system, this is the subparts. Say for example, gear system, gearbox, you have different subparts, you have different functions. So for the individual function, you need to generate ideas and what is the cost saving or a value improvement. So you need to have the template like this, then you need to go for your idea generation. So let me go with the simple two case studies. This is the first case study. In a case study on value analysis of a alloy wheel, a passenger vehicle. First, you need to go for a orientation phase, or then you go for a information phase where you need to collect the information about the project. So here it is, the project here is the alloy wheel in a passenger vehicle. So you know that the function of a wheel, the function of the wheel, you know. And here you have different type of the wheel strategies. So you, with respect to cost and with respect to value, you need to have. So the wheel can be with a hubcap, it can have a half wheel cover, it can have plain full wheel cover, or even it can have alloy wheel. So when you have the alloy wheel, it is having higher value. At the same time, the cost is also going to be higher. So now the need has come to reduce cost of this alloy wheel without affecting the function of the wheel. And you know, the alloy wheels are very costly, and it adds the cost to the vehicle selling price. So here you need to find an alternative to alloy wheel at a lower cost, and which will penetrate into the market with lower power cost with respect to the competitor in the particular passenger vehicle segment. Okay, and this alloy wheel, the alternative can be the steel rims with full cover, or the steel rims with half full cover, or even the steel rims with hubcap can also be a good one. But when you go for an alternative, the value gets reduced, but the cost can also come down. But our objective is to increase the value, okay, not to reduce the value by reducing the cost. So I need to find some alternative for this alloy wheel. And the current aluminum, the material of the alloy wheel is aluminum. This is the material. The material is aluminum A356.2. And here I'm going to collect all the information with respect to regulation, validation, durability, benchmark, styling, marketing inputs, drawings, cost sheet, and what is the finish, what is the paint, what is the treatment that you need to go, what is the overall weight of the wheel. So all this I need to get in the information phase. Next is nothing but a function phase, where I'm going to create the function. Class diagram I'm going to create. So here you need to list down all the parts of a vehicle, of a wheel. So you have the wheel trims. What is the basic function of a wheel trim? It should support weight, it should transmit torque, it should mount tire. But normally you should go with only one basic function when you're going for a fast diagram. What are the other functions? It should maintain air pressure, it should provide the brake cooling, it should mount air valve, it should mount weight, it should mount wheel cap, it should sustain torque, it should enable painting, it should maintain clearance, it should improve appearance, it should provide smooth traction, it should meet testing, durable, the ELVD requirements, and it should control imbalance, it should also control runout. Okay, now we are going for a fast diagram. So what is the basic function of a wheel, alloy wheel, is to transmit torque. Why to transmit torque? To rotate. So when you transmit torque, automatically the tire gets rotated. Our scope is only basic function. So how to transmit torque by hub and tire? This is a scientific function. How to connect hub and tire by clamping hub? How to clamp hub by mounting tire? How to mount tire by providing material? So way to provide material to mount tire, to clamp hub, to connect hub and tire to transmit torque. So when I'm transmitting torque, I am also and also in all conditions it should transmit torque. And the project objective is to improve appearance. Okay. The one-time function is to meet regulation, at the same time it should also maintain the packaging requirements. So what are all the order function? It includes cool brakes, mounting the tire, smooth comfort, controlling the imbalance and runout. All these are the order time functions. So now I'm going for a cost function worksheet. So I'm going to take all the functions from the fast diagram between left scope line and right scope line. So I'm going to allocate the functions for the individual to give one terms of percentage. Okay. So out of 100%, I'm going to give 10% to support weight, 10% of the cost to transmit torque, 8% to mount tire. So these are nothing but a function cost. What is called a function worth? I told you that worth is nothing but the least minimum cost which are required to achieve the particular function. So to achieve support weight, the least possible cost is only 5 rupees, 5%, not 10%. So this can be achieved with steel material. Currently we have aluminum alloy. So this can be achieved even with a steel material. And even the transmit torque can be achieved with the help of the steel material. And you see, improve aesthetic is one of the things where the function cost is 40%, but the worth is only 5%. Okay, there is a huge gap. The value gap is too high, almost 35%. The value gap. When I told you, when you have higher value gap and higher value index, you should always look for some alternative. Alternative here in the sense on the basis of worth, and that alternative will help you to go for new idea generation without affecting the function. Okay, so how to improve aesthetic? So improve aesthetic by way going for a stylish steel trim. Without aluminum trim, I can go with a steel trim and having the plastic cover in it. Okay, now I'm going for a creativity phase where I'm going to create ideas considering the functions. So here the top 3 functions here is transmit, improve aesthetic, transmit torque and support weight. So for these 3 functions, which is having higher value gap and higher value index or higher function cost, for these 3 functions, I'm going to create number of ideas. To transmit torque, I can transmit torque using alternate alloy wheel materials. I can do some optimization using machining with dimension tolerance. I can reduce the thickness of rims. I can also do some design optimization with lesser number of spokes. I can also revisit the boundary specification without affecting performance. So when you go for a support weight, I am going to achieve the support weight function by reducing the thickness of rims, by going for alternate alloy wheel material, machining optimization. I'm going to reduce the number of spokes also. So I have different ideas. When I'm going for a aesthetic, what I'm going to do is that I'm going to go for a top coat lacquer instead of a paint. Initially, it was with paint. Now they want to go with a top coat lacquer, and they can also go for a stylish steel rim with dual tone plastic cover. Okay? And you can also go for alternate raw material. So these are the ideas. You have different ideas, and next you have to evaluate the idea. Okay, whatever ideas you have taken here, it is not that all the ideas are correct. So you need to take the ideas which is having the highest ranking based on the benefits, implementation time, manufacturing feasibility, performance. So considering that, so out of 5 ideas, the ideas for transmitting torque, the best idea is to go for the alternative raw material for alloy wheel. And for to support weight, I'm going to get the highest ranking to use of alternate raw material for alloy wheel. When I'm going for the aesthetics, to improve aesthetic, I'm going to get the idea to use a stylish wheel rim with dual tone plastic cover. So I need to evaluate the ideas, and based on the evaluation with the ideas which is having highest ranking, you need to take it for implementation. But again, I told you, you need to go for the analysis, which is easy to implement and high cost saving will be higher. Sometimes the implementation may be hard, but the cost will be higher. So you need to go for a use of stylish steel wheel rim with dual tone plastic to improve the aesthetics. And again, you can also go for a use of alternate raw material in alloy wheel. So combining these two ideas, you're going to get a very good cost saving. So, and again, during development phase, you also need to do a lot of validation, DVP. So for this particular application, you have done a lot of validation with respect to material property, resistance, thermal resistance, chemical resistance, environmental resistance, and you also done a lot of we have done a lot of vehicle level testing, structural durability test as well. So here the two ideas is the first idea is we are going for a stylish build rim. This is after VAV, it is stylish build rim. Initially it was with alloy build rim, and here after VAV, without affecting the function, we are going for a stylish build rim. And initially you had a back plate alloy wheel with a hubcap, and we are going for a dual tone plastic cover. And here you should have a lot of cost saving. The cost saving is much huge higher here, and the tooling cost, but you also need to spend some money for the tooling, material costs, etc. Okay, so this is the alloy wheel on a car. This is the Duralloy rim having a stylish wheel rim. Okay, the cost saving is lesser. At the same time, you can see the style is also much more better. The aesthetic is improved without affecting the function of transmitting torque and the supporting weight. And here we use the dual tone new gym rings. You see, this looks very good in aesthetics. The cost saving is also lesser here. Here we are going to implement ideas by step-by-step process. Even after the validation, you are also going to do the releasing of drawing, then finally go for implementation. And you need to do all the things. This is just the tentative figure that I have given just for an example. Say the idea investigation started in the year April 2018, and then you start with the design, then you go with the CAE, then you go for a styling approval, then you go for a drawing release, availability, then review, then go for a validation, then DVP completion, etc. All this you need to do it. Then finally you go for a validation, then you implement it. So, so what is the benefit that you're going to get out of this? You're going to have 50% cost saving with respect to the alloy wheel. And even this can be applied even for a new segments also. And you're going to get a stylish look, and this will help you for the value improvement. This is the last example of an infotainment system. With this, I'm going to close, and maybe you can put your queries in the chat box. Uh, What is priority? The question comes here is what is priority or satisfaction? Okay, so the priority here is always a customer satisfaction, but normally the customer will expect with lower cost. Okay, at the same time, they also want the functions or the performance. So here the priority is the functions. Function is your priority. Or when you achieve the function, automatically the performance will be better and ultimately you can satisfy your customer. So the functions with optimum cost that could be your priority. Obviously, you can easily satisfy your customer if you achieve this. So this is the second case study, uh, which involves the value analysis of infotainment in a passenger vehicle. It is a infotainment system. So what is nothing but a vehicle infotainment system? It combines the entertainment and also the information display to the driver and also to the passengers through audio video interface, touchscreen, and also button. So the infotainment system. This is the flow of the presentation. And the project is being selected considering the higher overall infotainment cost and higher annual volumes, and also there is a scope for VAV study. And even you can select with respect to the parts having high cycle time, high process cost, and also the number of assembly. But this is not coming into this category. So for this infotainment, the overall system cost is higher, but you also have the higher annual volumes. If you reduce the cost in one vehicle, you can save in other vehicle as well. You have a lot of scope for VAV study. So this is the infotainment system having the floating display screen. This is the silver box housed behind the glove box, and this is the speaker. Speaker is also a part of infotainment. So these are a bill of material. You have one display screen, one silver box, four speakers, and four tweeter and one microphone. And this is the infotainment cost distribution. The major cost goes to the silver box. Next, it goes to the display. Next, it goes to the speaker. Then it goes to the tweeter. Then it goes to the microphone. So as I said, you need to start with a random function, the basic function, and secondary functions. What are the functions of a vehicle infotainment system? It should deliver entertainment, basic function. It should display information. It's also a basic function. So it should transmit energy. It should enable an input. It should display graphics. It should process information. It should enclose components. It should enhance aesthetics, support components, amplify signal, transfer heat, convert energy, regulate energy, store data, provide interface, and also fix components. So you need to list down all the functions. But here, it is having different parts: display screen, silver box, speaker, tweeter, microphone. But I have clubbed everything in a single thing. But you need to individually write down the functions. Then you need to go for a random or a fast diagram. And you need to go for a how logic, why logic. The basic function is to provide the interface, basically to entertain the user. How to provide a user interface by providing input. You have different functions with respect to different applications. For example, you have the settings. You can also change the setting. You can also connect the USB to your infotainment. And receive the signal. It can be AM or FM. Back to the cost and work analysis. So with respect to the individual function, what I told, you need to understand what is the function cost and also function worth. So when you have the gap between the cost and worth and function cost by function worth, there is always a potential. You can look for new alternatives. So you find the gap is more here to deliver entertainment. So the worth here is to use common standardized display, and to transmit energy, you can also look for reducing the wire size or length reduction can be an option. And there are some other examples. To fix component, you can also look for to optimize the infotainment mounting points. You can reduce the number of mounting points. That way, you can also reduce the value gap. At the same time, you can increase the value. There are different other ways, like PCB size reduction, integration of speaker components, reducing the thickness of heat shield, integrating the component display unit. So, but you need to consider the basis of worth considering the functions. Okay? Function is very much important. Always function is very much important. Then you go for idea generation. So this idea generation is basically coming from the functions. So for delivering entertainment, you are going for ideas to integrate the display and silver box. To go for a bigger 7-inch display, which is a new generation and commonized panel in the world electronics market. So by this way, you are going to increase the value at the same time you are going to reduce the cost. For displaying information, you are going to use low latency display within permissible limit. And to transmit energy, I'm going for a wire size and length optimization and the plastic connectors in place of special connectors. So like this, I'm going to generate new ideas for the individual functions. So what I'm going to do is that I'm going to evaluate the ideas with respect to the benefit, cost of implementation, manufacturing feasibility, and also the environmental resistance, etc. So what I'm going to get is I'm going to get more points for ideas to use 7-inch display, which is a new in generation and commonized in panel in the world electronics market. So when I go for this 7-inch display, the cost is going to be lesser. At the same time, the performance is going to be better. And I can also go for a standardized plastic connector in place of special connectors. And I'm going to get some other ideas to go for elimination of physical buttons by integration in software. Sometimes you don't have the buttons nowadays. You just a touch screen. Okay. Even you can go for that ideas when you're going for infotainment. And you can go for a next generation low power and low cost integrated circuit. And you can go for a develop adaptive based software for different platform to reduce software cost. So here the function is of our interface, and here the function is to process the information. You are going to select this idea for this particular function, this idea for this particular function, so this idea for this particular function. So finally, you're going to go for a tabular column. So you need to put the ideas whatever you selected, whether it is easy to implement or is it hard to implement, what will be the cost saving. So saving cost is lesser and it's a bit difficult to implement when you're going for a developing adaptive based software. And when you're going for a new generation 7-inch display, the cost is lesser. At the same time, the implementation time is also easy. Okay. So like this, you can go for it. And again, you need to go for uh, the development where you need to do all the thing, etc. So initially it was 6.5-inch display screen. You are going to instead of 6.5, you are going to commonize it 7-inch. It's not that because of the size increase, the cost is going to increase. So now this 7-inch is a new generation one, which has been commonized across all OEMs basically. That's why the cost is also going to be going lesser. At the same time, the performance is also going to be higher because it's the advanced version. So again, you need to have the development plan when you're finalizing the concept, when you're going to get the part for validation, when you're going to have the drawing release, when the product will come for a production, then when you're going to implement it, you need to have the plan for it. Okay, so with the help of this, I'm going to have the cost reduction of 15%, and I'm going to improve the value improvement for the customers, and I'm going to have better software which will be commonized across the various platform what we have. Now I will show you the website of the value engineering, Miles Value Foundation, and also the Society of American Value Engineering. So you can also contact me if in case if you need any clarification. Even I can help you for the certification program. I can also help you for your internal company trainings, and also for your own benefit. I can be a part of a mentor. Okay. So thank you for an opportunity. So the value is the vision. You should always consider value is the vision. Mighty function cost worth analysis. Function cost worth analysis. You call FCWA. Function cost worth analysis is the mission. You should bring the worth to the cost. So that's why the function cost worth analysis is the mission. But always ensure that function is the foundation, and function analysis systematic diagram is the mortar. Because considering the function, you are going for a new ideas generation in the creativity phase. So that's why function is the foundation, fast is the mortar. And now I'll go with some of the website. Just I will show in 2 minutes. Then you can ask your queries. You can parallelly, you can also put your queries in the chat box, or you can also ask your queries. Just give me a minute. I'm just going for a website.
Yeah, thank you, sir. Thank you for the session, sir.
Yeah, parallelly.
Yeah, yes, yes.
Ilango, we can ask the participants to have some questions, at least a few questions, because
That's it. Yeah, participants.
Yeah, before going for a session of questions, I just saw the website.
Sure.
Okay, sir. Okay,
Yeah.
okay.
This is the Miles Valley Foundation in the name of the Lawrence D. Miles digital website. You can get a lot of information about some of the videos. You can get it about the functions, about the value. You have generic examples, not with respect to automobile alone. You have generic examples. You can have a surfing over it. And you have one more website called Society of American Value Engineering. This is nothing but the SAVE International stands for Society of American Value Engineering. You can get, you can have a surfing over it. So here you can see the certification program, where Value Methodology Associate certification is, you can get the details. As I said, I am one of the instructor for this. You can also find the instructor name. So here you can get into the details. Even you get a lot of e-learning portals, get a lot of information about value engineering, value analysis, value methodology. At the same time, you get a lot of standards. You get a lot of things. You can have a look over it, and you can look into it. So now it's the time that you can ask the question. Thanks a lot for an opportunity.
Now, Mr. P.Arjunraj, there's this thing called random function analysis. Why is it called random? Any idea? Because what is the meaning of random there?
Okay. Before you go for a fast diagram called function analysis systematic technique diagram, you go for a random. Like, so here you look at the product, then parts, then for individual parts, you are writing listing down all the functions, uh, which involves not only the wanted function but even the unwanted functions also. Okay, so sometimes you may come up with some other functions which are not required, but still you may write it. But when you're going for a fast diagram, function analysis systematic technique diagram, you need to follow the logic, how logic, why logic, and you should list down the functions in the random diagram, and you can also eliminate the unnecessary function. And again, you are going to randomly write it, which means there is no. It is just like a rough draft what you have. It's not a final draft. The final draft is nothing but the fast diagram, and the final draft will be better when you have the proper rough draft. So that's why it's coming under random category.
Okay. So you list all the functions randomly, meaning
Yeah.
any specific order, you aggregate them, and you start looking at functions systematically and go from the highest order function to the lowest order function.
Yes.
Is that right?
Yes, you are right. Yeah.
Okay. Now, I've seen TRIS has used value analysis, very systematically also. And of course, starting from what Mr. Miles had introduced in the 40s and 50s. So, can you comment on TRIS as a tool for innovation? You had said brainstorming and creativity.
Exactly. Yeah.
But is there any merit to using TRIS as well?
Yeah. So see, you can combine this value methodology with lot of tools. Okay, it can be Six Sigma, it can be Trace, even artificial intelligence also can be clubbed for this value methodology. So here, Trace is a very good tool, and we can because that helps to for getting new ideas. Even with respect to some of the failure kind of thing, some of the new innovative ideas we can get using Trace, which is not possible with the other technique. And definitely this will help to go for new innovative ideas without affecting the functions or the performance. And definitely this value methodology through tricks is a good process, and it's a good way forward as well. Even this apart from tricks, even the Six Sigma can also be a good tool. And at the same time, uh, nowadays what we are exploring is that we are also going to explore the artificial intelligence along with the value methodology approach. So because this artificial intelligence will help for a new idea generation. It's similar to TRIS, but in different manner. But as far as the automobile is concerned, this TRIS is playing a vital role. And yes, this TRIS is yeah, one of the advantage that we have through which we can achieve the value methodology.
Sure. Thank you. There are many other questions in the chat box.
Yeah. I'll just look into the chat box.
Yeah. Thank you for your response, Mr.
Yes. Okay. The priority here is what is a priority. So I told you the function, and the cost is the priority, and finally you get customer satisfaction as well. Can we apply this methodology in development? Yes. This value methodology can be applied in all stages. And so as I said, you have the different stages: concept stage, design stage, development stage. You can put it. You can apply this value methodology. As the digital engineering is very important in reducing development time. Yeah. So as the digital engineering is getting very important in reducing digital time. Yeah, now we are going completely with digital, and this will help you to reduce the development time as well. Yes, of course, you can use this value methodology even in that aspect as well. So how to apply it in making whole development process agile? So here I'm getting the break with respect to the question itself. So how to apply it? How to apply it? Can the particular person can ask the question using voice so that it will be easy for me to understand it? Listing all is important in the random function. Yes, it will be better if you list all the things so that you can include all the functions in the in the fast diagram. Value stream is also part of this. Yes, yes, but value stream mapping is not going to concentrate on the function, but this value methodology is going to concentrate on the function. Even you can integrate this value stream mapping along with value methodology as well. In addition to the Six Sigma or TRIS, whatever tool. And this will help you to increase the productivity at the same time, increase the overall effectiveness. Generally, what should be the duration of value engineering project? So the value engineering project gets varied with respect to the product to product. Say for example, if the product is very simple and if the product is very complex. Say for example, you have different parts in a vehicle. It can be brake, steering, or a suspension. And if you're taking engine as a big project, okay, the duration can be higher. And when you take a small brake alone, okay, the project can be lesser. The duration can be lesser. So it will vary. The duration of the project will be vary depending upon the complexity of the project. Cost worth analysis to identify worth of the function when we are having the total cost with us. Yes. So here you need to identify the worth, and that identification of worth is possible only if you have very strong knowledge on the particular product and again the cost of the particular product. So for example, I give a lot of examples to transmit torque, support weight, sustain load. You have different function cost and also function worth. I will just give you a very simple understanding of the worth. Worth is nothing but the least possible cost to achieve the function. I'll just give an example of a general day-to-day use. You had a laptop with you. The laptop cost can be 10,000 rupees. Same laptop can be 1,50,000 rupees. The Apple product or laptop, okay. So the worth of the laptop is only 10,000. The function cost is 1,50,000. But you need to understand on what basis the 1,50,000 cost had been given by the Apple company. So here you need to have the knowledge about the product, not only the knowledge but also the process which are required to execute a particular product, and what are the different costs involved to achieve the 1,50,000 rupees. Why not 10,000 rupees? Okay. So if you have the knowledge about the particular product and the cost of the particular product, then only you can estimate the worth in a very proper manner. Otherwise, you cannot rate the worth. You may go with the wrong data. So in order to have the more accuracy, you need to involve the team, having the suppliers. Even the suppliers should be a part of this. They will give you the correct estimation, and the purchase team should be a part of that. Sourcing team should be there. Costing team should be there. Even you can also use the sub cost analysis. So all this will help you to go for a worth. It will be almost meeting the requirement of your cost. The specific use of simulation software in concept versus hardware testing, how to apply value engineering. Okay, so you can also go for a simulation software to test it, like the CAE or whatever the simulation you have. You can go for this and you can apply this value engineering. But this value engineering, you need to identify the project only based on the brainstorming and then based on the cross-functional team. That's why you need to form a team having the different expertise. They will help you find out the project. After selecting the project, then you can go for the functions. Then you can go for a creativity phase. Then you create the ideas. Then you evaluate the ideas. Then to develop the ideas, you can go for a software. How to apply value engineering to eliminate or reduce the prototype testing? Okay, good. This is a very good question. So you can apply the value engineering to to eliminate the prototype testing, say for example, which is the best way to go for a prototype? Okay, is it rapid prototyping, and even the rapid prototype you have different methods. Okay, you have SLS method, you have different methods. Okay, which is the least possible way to reduce the cost? Or sometimes, say for example, I will tell you another way. You are going with a lot of durability tests, 1,000 hours test, 500 hour test, 2 lakh kilometer test, 1 lakh kilometer test. Suppose if instead of 2 lakh kilometer, even you can give clearance even if 1 lakh kilometer also. If you are not finding any performance issue in 1 lakh kilometer, then obviously you can also do some optimization even in testing also. Okay, during the validation as well. But at the same time, uh, you should have the sufficient data to ensure that uh, you are going to have the better performance over its operations. How to apply value engineering to eliminate sometimes the prototype is required or testing is required. Sometimes it may not be required, but you need to identify whether it is required or not required. And again, that is the requirement is based on the cross-functional decision. Basically, for a safety aspects like brakes, when you're going for a testing of brakes, you need to test it. Then only you need to go for a clearance. Where the safety is more important, you need to do the validation. Can we get the detailed case studies? Any online links? No, currently there is no such case studies which is available online. Okay, there is no specific simulation software which is available for this value engineering specifically, but it's only all based on the simulation like what you use using the brainstorming method. Yeah, thank you. If you have any other questions, you can ask. Okay, so there are in the website whatever I told you can get some case studies, but it may not be related to automobile, but you can experience the value engineering through that particular case studies. Thank you. Thanks a lot. If in case any no doubt.
Yeah, thank you, Mr. P.Arjunraj. I would really, we appreciate your time and the comprehensive presentation you've made today. I'm Kannan. I'm the chairman of SA India Bangalore section. I was there throughout the entire session today, and it adds a lot of value.
And again, the time duration is very less, but still I took more time because still it will be very difficult to understand because it is very long. It is again you need to practice it in a very consistent manner. So I have seen some of the message which they are also asking some of the workshop kind of thing. Maybe say India, the individual section can help to arrange some of the workshop.
Yeah, we can actually do a professional development program where people can come and learn this methodology. It can be a 2-day or a 3-day, or depending on the objectives. We will certainly contemplate that because this is a topic that is very important to remain competitive.
Yes.
The industry, no matter whether it is 2-wheelers, 4-wheelers, or commercial vehicles, or other off-highway vehicles, this is very important, and this is a source of innovation. Understanding functions and the value those functions provide with respect to the cost that you incur in terms of resources used. Right? It's a cornerstone of innovation, and there can't be any innovation without understanding functions and value. So from that standpoint, I also understand that you do some work on technical innovation. These are innovative case studies that what we have shared with us today. So I think it's very good, right? From what is value? You started with what is value, function by cost, or function by resources. Then functions always remain, but only the solutions can change. There can be a variety of solutions to offer the same set of functions. and there's nothing unique about the solution. And you choose a solution that is least costly so that your value increases, right? So all the design to cost ideas, right? I think fast diagram is something most of us would have learned for the first time here. We might have heard about it, but today we saw what is exactly this and how is it done systematically. You showed it for some at the component level, at the subsystem level, in the car door trim case, and the infotainment case study, and the crankcase, and even for process, connecting rod. I think that, of course, you had addressed it much earlier. And both on the product and the process side, you touched very comprehensively. The whole spectrum of value methodology was presented. And you went all the way up to value, function, cost, and worth. It is very, very, very riveting session today, right? We really thank you so much for your time and dedication to bring this topic today to all our SAE members who are participants in the session today. We will certainly get back to you to look at a professional development program for our membership community.
Thank you.
Right. Thank you. And thank you for your time, and we'll stay in touch. And thanks, Elango. Thank you. And we thank SA India for bringing this value to our members. And we'll explore the next level of engagement with Mr. Arjunraj on this topic. Anyway, we have all your email IDs. We'll keep communicating with you. Right?
Thank you, sir. Thank you much.
Thanks, Elango. Thanks, Mr. Arjunraj, and thank all the participants for being a part of this session today. Thank you very much.
Yeah. Thank you, sir. Thank you much, sir.
Bye.
Thank you, Arjun, sir.
Yeah. Have a good weekend. And
yes. Thank you, sir. Yes.
Bye. Thanks, Mr. Arjunraj. Thank you.
Thank you.
Thank you, sir. Bye.